On Blackboard, you're going to find a sensitivity analysis steps worksheet. This is that Word document right here. And this is a walkthrough on how to conduct step by step the sensitivity analysis on Excel. I'm going to use the Lesson 13 house buying problem, which is also on Blackboard, and you can go ahead and download that and follow along if you would like. What we're going to do is we're going to conduct sensitivity analysis on a single value measure square footage. So just as an orientation to this spreadsheet, very similar to the car value PL Excel spreadsheet that you've used in the past. This case though, I'm just comparing different candidate solutions that are house options that I'm looking at buying. My 4 value measures are square foot, schools rating, number of beds, and number of baths. And I have 4 candidate solutions, the baseline and the ideal. My 4 candidate solutions are Phoenix, Salt Lake, Las Vegas, and San Diego, and then my baseline and ideal. I have all my value functions here, the data, and then the graphs for them below. My value matrix represented here, my weights 100 swing weight for square footage, 60 for schools rating, 50 for beds, 35 for baths. You can see from my values, my total values after conducting the additive value model, my total value for Salt Lake is 93, which is the winning solution. I also have a improved candidate solution here, but we'll get into that in next lesson. But for now, the total value is 93 for candidate solutions, for Salt Lake candidate solution. Below that is Las Vegas, then the baseline, then Phoenix, and followed by San Diego. Here's a stacked bar chart for it, and what I'm going to do now is just show you how to do the sensitivity analysis and build the graph. So the first thing I'm going to do is just copy all of my candidate solutions. And one thing to note for when you're doing sensitivity analysis, make sure that you don't try to do this on a different worksheet. If I tried to do sensitivity analysis charts over here in costing and trade-off analysis, or I created a new one, data tables will not work on different worksheets, so make sure to keep it on the same worksheet. I'm going to remove improved candidate solutions. I forgot my ideal. I'm going to add the ideal in there. Whoops. Let's go with that. Okay. Now, not to get too far ahead of myself, I want to make sure that I follow the steps on the worksheet that we have. So step 1 is enter the range of measure weight changes you want to explore using 0, 20, 40, 60, 80, and 100. So that's what's indicated in these yellow boxes here. So I'm going to put those right up here. I'll give it 1 column, and then I'm going to go up a row. So I'm going to start with 0 here, 20, 40, 60, oops, 80, and 100. And actually, I'm a little bit high because this is just a header, so I can go down 1. Okay. Now here I want to put my values. I want to have a reference to my values. Just as step 2 indicates, I want to reference the values in the additive value model, and I'm going to do that by referencing these values. So the spreadsheet shows you how to use, or the worksheet shows you how to use the paste link function. So I'm just going to go ahead and do that. It's also very easy to just use a reference, and that is hitting equals and then clicking on the cell. But I'm going to use the paste link function. So I'm going to select everything up into my baseline. I've got this improved candidate solution, which is going to mess me up, so I'm just going to avoid that for now. But I'm going to copy all these from Phoenix to baseline. Right click in Phoenix here, go to paste special, and paste link. and it just references the cell that gives me the total value. And then I need to do it for my ideal, so I'm going to copy this, hitting Control C, right click, paste special, and then paste link. Okay, so that accomplishes step 2. Now for step 3, grab the box area of the data output table, starting with the unused cell in the upper left of the table, and then go to data what if analysis data table. This is the unused cell up here, so I'm going to select all of this. I'm going to go to data what if analysis data table. Row input cell. So the row input cell is the cell that we're going to reference for swing weights. So if you remember, we talked about using the square footage swing weight. So by clicking square foot swing weight 100, what I'm saying is I'm going to do this this data table. I'm going to build this data table by seeing, well, the output of the data table will be what the values would end up being if I change this swing weight from 0 to 20 to 40 to 60 to 80 to 100. And we know that the current swing weight is at 100. So this column right here underneath 100 should be the same as the original over here, and that'll be the kind of validation that we did it right. So for my row input cell, I'm selecting the swing weight for the value measured that I'm interested in. I'm going to hit OK, and if all goes well, the table will be populated. And just to do a check, like I said, we want to make sure that these values are equal to these values, and with a quick cursory look, it seems like they are. So I'm just going to change these decimals to ensure that they're 2 like the other ones, just to call down some of the decimal places. Okay, so our data table is now complete, and now what we can do is we can plot it. And I can go to my spreadsheet in the second, or my worksheet in the second page is a tutorial on how to plot each of these solutions. So I'm going to hit Control here. I'm going to highlight all of these, and then these, insert, and I will be honest with you, I'm not extremely good at making charts. I can never seem to get it done the first time. But what I'm going to do is I'm going to take this chart and I'm going to select the data, and I'm going to end up having to clean this up quite a bit to make sure that my alternatives, I'll just do one of them here. I'm just going to start from scratch. So my series name will be my alternative. My X values will be everything, or all the swing weights as they change from 0 to 100. So I'm going to highlight that. And then my Y values are going to be the value of the alternative. And there's the first line. I'm just going to do this for all the other ones. I'm going to pause it, and then I'll reconvene once I have all the other ones. Okay, so after adding all the other alternatives, you can see this is my completed sensitivity analysis for square footage value measure. I also changed I formatted my axis so that it ended at 100, and I formatted the y-axis so that it started at 40, so it goes from 40 to 100 instead of 0 to 100. But you can see through this sensitivity analysis that the winning solution across the entire spectrum from 0 to 100 is Salt Lake, and it does not change. There's no crossover. The winning solution does not change no matter what swing weight we're looking at. And one thing that I could do to just make this a little bit more clear is add the axis titles, and this on the bottom here is swing weight, the x-axis and the y-axis is value. So the swing weight from 0 to 100, does not affect the solution or the winning solution. It is always going to be Salt Lake. So we can deduce from this that our value measure is not sensitive. Okay, I think that's it. I think that's all I'm going to cover for this tutorial. I hope it helps. Take care.